All right, we're here at Geometry Chapter 2, Section 3, and this section is on mathematical modeling. So, mathematical modeling is just like trying to take the problem and make a diagram, make a table. You might do a tree diagram. We're going to be exploring different ways of modeling mathematical problems, both here and in class. We'll do a lot of them in class together. So I want to present the handshake problem. This is a fairly famous inductive reasoning problem, and I'm just going to show you one way to solve it. You guys might come up with different ways to do this, but this is how I put it together. So, the handshake problem. So there are 30 people at a party, and they each shake hands with everybody else. How many handshakes were there altogether? All right, so you need to figure out a way to organize some of this data. What I did is I made a graphic, and because we're in geometry, I always like to use geometrical shapes and to just visualize what's happening with this handshake problem. So if there's only one person, there are no handshakes. If there are two people, there's only one handshake. If there are three people, there are three handshakes. Four people, there are six handshakes. And five people, there are 10, because you count the size of the polygon, and then you also count all of their diagonals. And then the next thing I do is I gather that data and put it in a table that looks like this. So one person, 0 handshakes, two people, 1, on and on and on. And what we're going to do is we're looking for the nth term. We want to look for a formula that will give us the answer to how many handshakes are there if there are 30 people at the party. Obviously, I am not going to draw a 30-sided figure with all of the diagonals. I don't even know if I could do that. So I'm going to look for a pattern and see if I can't come up with a formula mathematically. So the first thing you want to do when you're looking for a pattern is look at the differences between the outputs. And you'll notice that those differences are not the same. You might remember from Algebra 1, if there's no common difference between the outputs, that this is not a linear function. Okay, so what do we do now? Well, these are called, well, I call them level 1 differences. If the level 1 differences are not the same, I look for the next level. So now I want to look at level 2 differences, and I'm looking at the differences between these outputs. And you can clearly see that those are the same. Because this is a level 2 difference, I know that this is a quadratic function, meaning that somewhere my formula n is going to be squared. All right, so my next step, because I can't see a pattern between this number and this one, and I know that there are level 2 differences, I'm going to go ahead and take all these outputs. I'm going to write a new table, but this time the outputs are going to be multiplied by 2. So that means if n is 1, this nth term would be 0, 0 times 2. If n is 2, this number would be 1 times 2. So I'm going to go ahead and just multiply all of these numbers by 2 and write down the new output. This, as you may know, just means that the pattern goes on like this until we can discover the nth term. All right, so now I can see it. You guys probably can't because you haven't had a lot of practice with this. But I can see a connection between these two numbers, between n and its output. This one looks like 0 oops, sorry, is 1 times 0. 2 is 2 times 1. 6 is 3 times 2. 12 is 4 times 3. And 5 is 5 times 4. Notice that the first number in all of these are my n values. So I want to try and come up with a formula so that one of my numbers is n, and then I'm going to multiply it by, if this is n, this is n minus 0. If this is n, this is n minus 1. Oh wait, I knew something was wrong there. This is 1 times 0, not 1 times 1. So if this is n, this is n minus 1. If this is n, this is n minus 1. If this is n, this is n minus 1. I found my pattern. I found my formula. Except, how did I get these numbers? These right here. Don't forget that I multiplied by 2 to get those numbers. I have to undo that in my final formula. And to undo multiplying by 2, I'm going to divide by 2. And now I know, well, I don't know for sure because I'm going to test it, because I might have made an error. But I'm assuming that this is my nth term. Let's see if this works for the first one. N is 1. 1 times 1 minus 0 is 0. 0 minus, or divided by 2 is 0. When n is 2. 2 times 1 is 2. Wait a minute. 2 times 1 is 2. Well, I'm supposed to be going up here, I'm sorry. 2 times 1 is 2. 2 divided by 2 is 1. Okay, now let's try 3. 3 times 2 is 6. 6 divided by 2 is 3. So guess what? If it works 3 times in a row, you know you've gotten your formula. But let's just test it one more time on this one. 5 times 4 is 20. 20 divided by 2 is 10. So now we can answer the question, how many handshakes are there if there were 30 people? So n equals 30. So the number of handshakes is 30 times 1 minus that, divided by 2. Let's see, I have my calculator on, so hang on a second. And the answer is 435. This is way easier than trying to draw a 30-sided figure, wouldn't you agree? Like I said, we're going to practice a lot of these in class, and we are looking for patterns, and we're looking for ways to use mathematical modeling to solve problems. All right, that's it. Thanks for joining me.